So, well, as mentioned, I'm not going to go through the whole protocol itself. I'm just going to quickly go through what has been changed in the protocol, which are just few minor changes, and to what we understood to that have been the main difficulties encountered by some, or in some cases most, of the collaborators. And also, after the meeting, I'm going to send to you, some of you may have already received it, but I'm going to share with you a file where the whole protocol is described, and with links to the recordings of the online courses which were held in 2022, so that each part of the protocol is explained in detail. And also, I'm going to share with you a document where these aspects that I'm going to talk you through are also described. Yes, we, as mentioned, we only decided to make some minor changes because, first of all, the protocol in 2022 proved to be effective and reliable, and also we think that one of the most important parts of the observatory is the comparability, and therefore we also believe that to be able to compare results between years is fundamental for us. Therefore, we don't want, and also don't need, but we don't want to drastically change the protocol. Also, some of the changes allowed us to enhance the protocol, discarding the parts that are not fundamental, that became not fundamental for how the protocol has been developed in the time. Also, as Joaquin mentioned, there are some aspects of the protocol that could be improved, but in its implementation. So in light of the experience we gained in 2022, we believe we can get even better results and more reliable results in 2023, implementing the same protocol, but with more care and attention for some aspects. So the first change is related to the ground references which were needed for the implementation of the protocol in 2022. So I'm sure you remember this grid that you had to create on the ground, measuring the distances on the ground, placing stakes, and then replacing these stakes with natural marks. And this was fundamental. This was a previous approach that was used to then estimate animal movements, and therefore then to obtain day range and other parameters which are fundamental for the implementation of REM. However, last year, both these and photogrammetry approach were implemented at the same time, because we needed a backup somehow to be sure that the effort was not wasted in case the photogrammetry approach was not to be implemented correctly or was not to work to an extent. But since we understood that works and works well, this year that's not going to be necessary. This represents for the implementation of the protocol quite an important step, as this part was time-consuming, and we believe that without this step, the setup of cameras is going to be much easier and faster. The second change is related to an overall longer implementation period of the protocol. So it was finally decided to increase the activity of each camera to at least 4 weeks, and when possible 6. This also might depend on how many rounds and sessions are performed. In fact, if you only if you're doing 3 sessions, and this might be related to the number of cameras you have. In fact, it was set as a minimum number of cameras, overall camera point, 36 for the average extension of the study sites that are included in the observatory. However, if you're only doing 2 rounds because you have more cameras, perhaps you could also keep each camera active for 6 weeks. And this longer period of activity might allow us to get more contacts, especially for elusive species, which we could have had difficulties to get enough contacts of. So passing to what could be in some cases done better, and this might be or of some of the details of the implementation of the ability between the different study areas, which, as you know, is crucial for the observatory. So one of these aspects is related to the study design. In fact, what is proposed in the observatory protocol is to create a uniform regular grid, which is then randomly placed over the study site. However, not always the study design was designed this way, but sometimes it was a fully random design. So the cameras were randomly placed over the study site. But so what we want to ask you here is to, if you didn't already do that last year, to follow this structure that we are suggesting here. So as you see in this example, the cameras are deployed on a regular grid. So the 2 colors are referring to 2 different rounds. However, you see that the distance between cameras, whether within the same round or within the overall camera point, is approximately the same. Also, each round has to uniformly cover the whole study site surface. So despite it being more easier, let's say, you can't just say, okay, I'm going to deploy the first round in the northern part and the second round in the southern part. Each round, as you see here, if you only consider one of the 2 colors, each session covers the whole surface of the study site. Then, so moving on, this I know is going to sound obvious, and in most cases this was not an issue, but in some cases the camera setup was not great. So I would like just to quickly remark this, even though you all know how to set up a camera, but just to stress out the need of put attention on this part. So in some cases the cameras were not set perfectly, so they were aiming too low to the ground or too high, and that would make us lose not just a good part of the field of view, so potential context, but also you wouldn't be then able to use at its best the camera detection area. So the camera should be slightly aiming towards the ground, but not too much, because otherwise you would lose potentially important part of its field of view and its sensitivity, let's say. So if you can manage to have the horizon in the higher half, let's say, then this would allow you to get a good view of what is close to the camera, but also to use at its best the sensitivity of the camera in order not to lose any contact. So going to the important parts, the deployment calibration. This has been what I've experienced to be the most frequent difficulty that was encountered by most of the collaborators. So this part is crucial for the protocol that we are proposing. So most of the times, not most of the times, but often, not enough deployment calibration pictures were obtained. So according to the protocol, for each deployment, 25 to 30 good deployment calibration pictures are needed in order to get reliable results. So this step of the process is needed to allow the system to georeferentiate each pixel of the frame of the picture that you are obtaining, and that is then going to be fundamental, crucial for the estimate of the day range and estimation of the day range and the camera detection radius and angle. So here you see a good example of the deployment calibration pictures. So that is a good example because this is a good number of good usable deployment calibration pictures, and because these pictures uniformly cover the whole field of view of the camera. So as you can see here, it is fundamental that each picture, that we have good pictures for covering the whole field of view, so they don't have to be clustered close or far away from the camera, or if, as you see in this example, in the D example, if there are not enough of them. So what we suggest is that you do a trial at home before going to the field. So you can set up the camera in your garden, in your garage, in a room or that is large enough, and make a trial and see how long it takes to get enough deployment calibration pictures. In fact, once you are in the field, you're not going to be able to check, because once you set your camera up, you switch it on, and then you take your deployment calibration pictures, you're not going to be able to check, because if you touch the camera and you move it, and then this deployment calibration pictures are no longer going to be valid, because the reference has been moved. And also, if you are in doubt, just spend a few more minutes in this part of the process, because this really is crucial for the outcome of the data collection. And related to this is also the digitizing of the deployment calibration. So another point is as you see here, the raised thumb, that is extremely important, and that communicates when the pole is resting on the ground. In fact, that is fundamental, because as you can see in this picture here, you can't really see the bottom of the pole. So you need to communicate it while doing this, because otherwise you might have the risk of digitizing deployment calibration picture where the pole is not actually resting on the ground, and that would give false information to to the system. So what about the digitizing of the deployment calibration pictures? You always have to digitize the maximum height which is visible in the image. So, for example, in this picture here, you see that at the very top you have the edge of the 5 bands mark, which is 1 meter. So you would mark that, and as top of the pole, so that is 1 meter, and you would mark the 2 stripes bit where that is 40 centimeters. So the maximum height which is visible within the picture. So in this case, you don't want to digitize, let's say, the 80 centimeters and 60 centimeters. You always aim for the maximum height which is visible within the picture. Also, yes, as previously mentioned, make sure you make some kind of gesture to indicate that the pole is resting on the ground. And if you have, because you are going to have more pictures of you in the same spot with the pole, so in that case, you don't need to digitize it more than once. You only want to digitize it once because you're not adding any other information. So what we need is more pictures of the pole resting in different spots. So only digitize it once per position with the maximum height visible within the frame. Animal movement, this is another crucial part. So clearly this is related to the species you want to obtain densities of. So only for target species. How many sequences? Well, the more the better. However, at least 100, possibly 150 must be tracked, must be digitized for each target species that you want to obtain densities for. So each individual, in each observation, you can track one individual. You can't communicate to Agouti that you are digitizing 2 different individuals within one observation. Therefore, you are going to need a single observation for each individual that is being tracked, is being digitized. So what is going to happen in some cases is that you might have a single observation for more individual, because when annotating the pictures and the animals, you might have, for example, let's say 4 adult female rodeos. So in that case, you are going to create a single observation saying that you have 4 female rodeos, and they all belong to the same category, same sex class, same age class, and same species. So that's going to be one observation most of the time. If you happen to get to that sequence to be tracked, then you're going to have to create new observations. So you're going to have 4 single observations, each one of them with one individual. And you have to. So yes, if one individual is tracked within a sequence where more individuals are present, then all the other individuals have to be tracked as well. And another thing that is that it is fundamental that you select the sequences to be tracked randomly. So a way to do that can be to, once you have them processed in Agouti, that you select one sequence every X sequences, depending on how many sequences you have for that species, and depending on how many you want to digitize. But if you select them arbitrarily to some extent, then we're gonna have the risk of biases. Yes, finally, I'm almost done, is the importance of tracking the right food. So what we want to track, what we're gonna choose as tracking element is going to be the frontmost foot that is touching the ground. So in this case, this is going to be the front left foot of this main rodeo. And then we're going to keep tracking the same foot throughout the whole sequence. So it might be that in the picture after this one or the one after that one, the foot in front is the right one because the animal is walking. But what we keep tracking is what was the frontmost foot at the beginning of the sequence, and we keep tracking that foot. Also, you might see that most of the time the actual point of where the foot is touching the ground is a bit lower on the ground that you might think. But is a detail. But yes, keep an eye on that as well. Finally, if in the first picture, if this is the first picture that you get, you can actually see the foot, then you can still track it because you can point it out of the frame. So if you drag the picture, you move it, you're gonna see the boundaries of the frame, and you'll be able to digitize the point even if it is outside from the picture, and so you can guess where the first point of contact is. And so yes, that's it on my side. I've seen that some questions have been raised and a bit of a discussion was done, and so just if you have any question or if we want to discuss about it, please. I don't know if what was asked has already been answered. Lars?
Yeah, thank you, Antonio, for the explanation. I wonder about these positions.
I can't really hear you, Lars. I don't know if it's me or I hear you very far in the distance.
I have my microphone on now. Can you hear me?
Oh, no, Lars, the sound is not good. Sorry.
Okay, I can write in the chat. Try to write in the chat.
Okay, better, thanks.
I couldn't hear. I don't know if someone else heard that and could perhaps.
He's going to write in the chat because he has problems with the sound.
Great. Perfect. What about the positions? Okay. Well, if the study design was correct last year, you can repeat it, and that might be easier because you already got to the point. So of course you can repeat it. Otherwise, it's not a problem to have different points as long as the protocol requirements are met. Clearly, Marcus, Jim,
Take your position. Axi.
What I'm saying.
Hallo.
You're welcome. Jim?
Yeah, for me, it's now a little bit confusing about digitizing the different animals in the same sequence. I thought we had this discussion also last year, but in the beginning, if you had 10 wild boar running through an image, you had to track all of them because the number of observations, the number of animals was 10. And then I thought I understood that it was enough to track one animal through the sequence to calculate the distance and the speed, and that the number of animals was taken from the n, the count, to calculate the total densities. But if I understand Tancredi, now we should track all 10 animals if we want to use the number of 10 animals. So now I'm not sure anymore what we should do. And it's quite an important one because, like for wild boar, we sometimes have sequences with 25 animals. And if you have to track all of them individual, then it's a lot more work than if the calculations simply use the count number of 25 and use the tracked animal to calculate speed and average distance and whatever you want. So I think it's a very important one. And I thought last year we got the message that it was no longer necessary to track all 25. So I think it should be very clear before we start tracking the animals in the deployments or in the sequences.
Well,
maybe a question for Marcus. I don't know.
Yeah, shall I respond?
Yeah, please go on.
No, that's correct, Jim. We did modify it so that it was not necessary to digitize every individual animal that you see. So in that case, you need to sample effectively the animals that you digitize. So if you have for example, a big group of wild boar, maybe you want to select one or two that you will track, in which case, let's say you just select one, create one observation for that one individual that you track and do the tracking, and then create another observation that is has no tracking associated with it, but has a count that gives you the number of individuals, additional individuals that you didn't track. And that should be, as I say, on a kind of sampling basis. It's not an exact rigorous sampling, but what I mean is that you should try to sample some individuals from across all of your deployments and maybe from a range of different groups, rather than doing 150 all in the first 2 deployments, say, and not digitizing anymore. So that's I hope that's clear. Does that make sense?
Yes, it makes sense, but I think it also means that we should go backwards to some of the slides of where Tancredi said that we should track, to make an observation for each animal in the sequence and track each of them individual, because it's not strictly necessary.
Right. It's I guess the point is that you need to make, if you're going to track individuals, then there needs to be a separate observation for each of those individuals that you track. But you're right, it's not necessary to track every individual, and therefore you can have an observation that covers multiple individuals.
Okay, thanks. Clear.
Thanks, Marcus.
There is a question by Luca. So with the new update of AWT, I noticed that the deployment calibration marks are no longer there. Is this a bug, or do I have to repeat all the calibration marks again? Maybe for AWT people. Jing, do you know?
I don't know. And I don't understand Lucas' question. Is he meaning the deployment calibration marks of last year or of a new round?
I suppose I can answer this question because I have such experience working with Agouti right now, because I have to digitize my next images from different species. And this is a bug, I think, because it is under construction now. And if you go forth and back in the same sequence, you will see your digitizing points. So there is no worries. But I would ask if Agouti will be under construction the whole summer, or it will be ready earlier than September, as Joaquin said.
And, I don't know if Jörg is here, but normally this is a release which has been tested quite good and strongly. So it's not really under construction. Of course, with each new release, in the moment we release it in production, we risk to bump into some small errors. So we will try to solve them, or they will try to solve them. But it's not that this is a. They have been working on this for quite some time, so it should be quite stable and quite okay.
Yeah, I think if we have some suggestions, we can write to improve the new release. Oh, okay, thank you.
Yes, your suggestions are always welcome. So please email myself or Tancredi about this, and we are in continuous contact with our colleagues from Wageningen and IMBO. Okay.
Maybe one remark to Luca, because he's saying about last year's deployment calibrations. Almost by definition, and Marcus should correct me if I'm wrong, but almost by definition, you cannot use the calibrations of a deployment of last year, even if the camera is on the same spot, because the camera has been moved probably and has been moving in some direction. So if you restart, you revisit the same place for a new deployment, you have to recalibrate anyhow with the sticks in the field, because there will be small changes. So it's not just copy pasting the marks of last year. That will never work, I'm afraid. Marcus, correct me if I'm wrong.
No, that's correct.
Okay, we had a question or comment by Pablo.
Yes, thank you, Joaquin. I'm wondering about the last discussion about tracking only one individual in the group and then include the group side. Because which should be the criteria to select, for instance, only wild boar in a group of, I don't know, 7 wild boars? Because I think that if, for instance, if we systematically select the closest wild boar, then the estimation of detection zone should be negatively biased. I mean, for instance, if the closest wild boar enters the camera 2 meters from the camera, but then we see the other 9 wild boars from 2 meters to 12 meters, let's say, we only will have one angle and distance to estimate, or one detection angle and one detection radius or detection distance to estimate the detection zone. So I'm wondering how then, when we include for this observation, for instance, 9 more wild boars or 9 more individuals, if this approach will not artificially inflate the densities. Maybe I missed some point.
No, I think that's a really good point, Pablo. You're absolutely right that there is a risk of that. So I think I was perhaps a little bit flexible there in the way I suggested the sampling happens. I think maybe there is some more thought needed on some guidance on that. I think maybe something like digitizing whole groups, if you're going to do that, rather or selecting those groups rather than, as you say, the first individual that may be the closest. But we should perhaps take a moment to come up with some guidelines for that, rather than making them up on the hoof at the moment. Maybe we need a little bit of time just to set out the guidelines very clearly, and then we can circulate those.
Okay, thank you.
Well, thanks, Marco. We are also going, I will ask Tancredi to include a note on this issue on the PowerPoint to be distributed to everybody. Okay. Amir, please. We cannot hear you. Okay.
Can you hear me?
Perfect. Thank you.
Hi, all. I have a few points. One is this is something I was contacting all of you, I think, or many of you last year. I think we need to have a protocol for choosing an alternative location once you go on the ground and you see that the random location or something like that is not suitable. You need to choose another one, and there it's very difficult to be unbiased towards a trail or towards not using a trail. So that's my main challenge, I think, and maybe you have ideas on that. Did you understand me?
Yes, perfectly. Yes, I think this problem is something that we everybody face once you are in the field and you have to select one new point because you have some issues in the such point where you should deliver the camera. Yeah, we had to think about this. Maybe some of you can comment on your experience, how you believe is the best way to do so the initial design still is appropriate and not biased due to this last time decision you take in the field. Okay, what do you think about?
Well, according to the protocol, but I understand that this might not solve the problem in some cases. According to the protocol, however, you can, if the point, if the exact GPS point is not suitable for some reason, you can move within a radius of 100 meters to find a more suitable place where to set up the camera. However, I understand that in some cases this might not solve it because the area, the whole area might not be suitable itself. But yeah, in many cases this might solve might solve the problem. Perhaps I'm not sure. Maybe Marcus can give more details on it. But if a larger area is not suitable for the use of camera, perhaps it has to be excluded.
Maybe I wasn't clear. So if that location, exact location, was not suitable, I move, let's say, 20 meters, but then I need to decide whether I cover now a trail, an animal trail, or I try not to cover a trail. So then you become biased because either you try to find a place with animals or you try not to find a place with higher activity. So I think we need something arbitrary for that.
So if I could
maybe
comment,
steps.
I think the least biased solution would be to find the nearest point at which you can place the camera. So there's no choice about where it's pointing towards a trail or whatever, but the nearest location where you can place a camera where it will have a suitable view should be the least biased location. And
can I add one thing to that? That you should attempt, where possible, to note the habitat or the immediate environment that the camera was placed in, and try to ensure that the where you end up placing the camera is in the same sort of environment. So if you the camera is in a dense bushy area, then try to kind of emulate that same sort of habitat, but keeping in mind what Graham said about having some sort of field of view so the camera can see something. So it's not a perfect process, but it's about trying to make sure that the camera represents the sort of area that the initial point was covering.
Okay, I have two other points. One is, should the field of view kind of be similar? Like maybe one camera could cover, like, I don't know, a distance of 50 meters sometimes if it's an open field, and another like 4 meters. And Agouti when you do the analysis, you don't take that into account, right? It's not like distance sampling or something.
No, it's very much like distance sampling. So that information will come out. So if you have cameras in more open areas, then they will see further. You'll have a greater detection distance. So the density estimate will take account of that.
Okay. And the last one, the calibration process, Marcus, the script you wrote provides these curves. And I was wondering that they show you when you need maybe to improve your calibration.
Yeah.
I was wondering maybe this could somehow be iterative so that you can really choose the points that you need to refine or something like that.
Yeah, I've been talking to the Agouti team about this. I don't think we have that yet, but it's on the list of things we need to work into the Agouti interface.
Cool. Thanks.
Thanks, Amir. Any question or comment?